Hello class, this is Mr. Plunce. We are ready to take notes for 10C. This is graphing and solving part 1. Okay, in 10B, you've learned the different techniques of solving, and in 10A, you learned how to graph things. So now, in 10C, you can do both at the same time. So you can see how the graphing solution matches up with the algebraic solution. So you have to solve it both ways to see how they relate to each other and to check your answer. And then you can mull over which you think is easier if you'd like, but you are required to solve it both ways. Okay, so the first problem, x squared plus 2. I'll attempt to graph this. Okay, let's see, x squared, I know it's a parabola, and plus 2 at the end. I think that moves it, I think a number at the end moved it up 2, but we haven't talked about that in detail. So I will go ahead and make a table for y equals x squared plus 2. So I'll plug in negative 2 and square it and get positive 4. Plus 2 is 6. I'll plug in negative 1, square it, get 1. Plus 2 is 3. I'll plug in 0 and square it, which is 0. Plus 2 is 2. 1 squared is 1. Plus 2 is 3. And 2 squared is 4. Plus 2 is 6. So negative 2, 6. Negative 1, 3. 0, 2. 1, 3, and 2, 6 is right there. So there's my parabola. This should have the standard shape, and plus 2, it looks like it moved it up 2. So this is the standard parabola. Now my line. So my line is y equals negative x plus 2. Okay, I can make a table for this. Wait a second. Negative x plus 2 is my y-intercept. That's right there. And then negative means my slope is negative 1, down 1 over 1. Down 1 over 1, down 1 over 1, up 1, back 1 is right here. So it would appear my solutions are 0, 2. So this solution is the solution. X is 0, y is 2. And it appears that that's a solution. That's negative 1, 3. So if I've graphed it correctly, those are my solutions. So if I solve it algebraically, I should get x is 0, and x is negative 1, because I'm going to solve it for x. And then if I want to plug it back in, 0, I can plug it back into the top or the bottom to get the y value. Okay, so here's the algebraic solution. So I will use substitution. I will substitute in negative x plus 2 in for the y. So I'm getting negative x plus 2 equals x squared plus 2. Now, I've got an x squared term and an x term. So this is the kind I want to set equal to 0 and try to factor it. So I will add x to both sides. Now, I will leave my x squared positive, so I'm going to add x to both sides and subtract 2 from both sides. Add x and subtract 2. So that cancels and that cancels, and I get 0 equals x squared plus x. And the 2's cancel. Now I can solve this by, well, I'll try factoring, and if that doesn't work, I'll use the quadratic formula. So I get 0 equals. So there's an x in both terms. I can pull it out using only one parenthesis. try one parenthesis first, not two parentheses. Now, x times x is x squared, and x times 1 is x. Now, what makes this part 0? Because 0 times any number is 0. So what makes this part 0 is 0. And what makes this part 0 is -1. So this solution then, x is 0, so that means it's 0 something. X is -1, so that's -1 something. Now, I should be able to plug 0 into the top and the bottom and get the same value for y. So this will check your solution. If you get different values, either this is not a solution or you made a mistake. So plug 0 into the top, 0 squared, 0 plus 2 is 2. -0 plus 2 is also 2. So 0, 2 is a solution. This is correct. -1 something is a solution. Plug -1 into the top. -1 squared is 1 plus 2 is 3. Plug it into the bottom to check your work. The negative of -1 is 1. Plus 2 is also 3. I have just checked my work. -1 is a correct solution. Oh, and look, I got it over there. -1, 3. And 0, 2 is correct. And look, I've got it over there. Everything worked out nicely. I did not make a mistake, and math isn't broken. All right, let's try the next one. Okay, let's try graphing it first. Now, did I give you guys enough room to make tables and whatnot? All right, so number 2. Okay, I don't think that was helpful. All right, number 2. Let's see here. Let's make a table. 4. Y equals the square root of -x minus 1. Oofda. So the square root graph, that's the sideways curvy thing. You can't take the square root of a negative, so let me think here. Okay, so if I plug in 1, I get 1 minus 1 is 0. You make it negative. -0 is the same as +0. The square root of 0 is 0. If I plug in 2, 2 minus 1 is 1. Make it negative. That doesn't work. That's a negative value. So 2 doesn't have an output. 3. 3 minus 1 is 2. Make it negative. I'm going the wrong way. So these values don't have outputs. I'm going the wrong way. Let me go back down to 0. 0 minus 1 is -1. That's good, because the negative of -1 is +1, and the square root of 1 is 1. -1. -1 minus 1 is -2. Now you make it negative. And you get the square root of 2, which is somewhere decimal. -2 minus 1 is -3. The negative of -3 is 3. And the square root of that is somewhere decimal. -3 minus 1 is -4. Make it negative. That becomes +4. And the square root of 4 is 2. So what have I got? 0, 1, -3, 2. Oh, and 1 was 0. Okay, so there are my 3 points. It starts here and goes this way. All right, I've happily graphed that. Now I feel like this x minus 1 does the same thing to each type of graph. I can't remember from A what it did. And I feel like this negative flipped it somewhere. I was trying to think back to A. I think these negatives flip it, either upside down or sideways. Maybe we should talk more about that at some time in the future. All right, now y equals 3 is a horizontal line through 3. Right there. Now, does this cross this? Interesting. Not yet, but if this keeps going up, I bet it will at some point. Let me think. So if this keeps going up, I need to take the square root of something and get 3. The square root of 9 is 3. So I wonder if way out at -8, because -8 minus 1 is -9, you make it negative, and you get +9, and the square root of 9 is 3. So at -8, I think I can just extend my graph out a little bit. -5, -6, -7, -8 would be somewhere in there, and -8 is 3. So if I graphed it more accurately, it would go up like this. And there it is right there. -8, 3 is the solution. So right here, the solution looks like -8, 3. Now, graphing this was kind of a pain in the neck. I don't know if I liked extending my graph. It got a little squishy. Let's see if solving it algebraically goes okay. So I'll substitute in 3 in for the y, and I will get 3 equals square root of -x minus 1. Now, to solve square roots, from the last worksheet, I want the square root by itself, which it is. When it's by itself, I will square both sides. The square root and the square cancel, and I'll get 9 equals the negative of x minus 1. I don't need a plus or minus because the square root of a positive and the square root of a negative are different. I will distribute my negative, getting 9 equals -x plus 1. I will subtract 1 from both sides, getting -x equals 8. I will multiply both sides by a -1, getting -9 equals x. I'm sorry, -8 equals x. -1 times 8 is -8. So my answer is -8 something. I can check my work by plugging it into the top and the bottom. If I plug -8 into the bottom, well, there's no x there, so I just get 3. So hopefully if I plug -8 into the top, I also get 3. All right, so I'm hoping that's a 3, this value. So it's the square root of the negative of -8 minus 1. -8 minus 1 is -9. The negative of -9 is 9. And the square root of 9 is 3. So sure enough, it worked into the top and the bottom. So it's right. And -8, 3 is the solution I got graphically. So everything, once again, is fine. Math is not broken, and I have not made a mistake. Okay, the next one. How many possible solutions? Well, it depends. Okay, so you've got square roots, absolute values, and parabolas. Okay, so let's think about this. If you have a absolute value and say a line, you could have one or no solutions, or wait, maybe 2. So you could have 0, 1, or 2 solutions, depending on where the absolute value and the line are located. If you have a parabola and a line, the same situation occurs. You could have 0, 1, or 2 solutions. if you have a square root graph and a line. You could have 0, 1, or 2 solutions. And if you have an absolute value and a parabola, you could have 0, 1, or 2 solutions. So all of these problems, you could have 0, 1, or 2 solutions. So 0 is probably the least common. 1 means if you get 2 solutions when you solve it algebraically, one of them doesn't work. So most algebra problems would have 2 solutions, so they both answers you get work, but occasionally one of them doesn't work. Like if you plug it back in, it might only make one of the equations true, not both. Or a problem could have 0 solutions, which isn't likely, but it is possible. Okay, so here are some problems for you guys to solve. Now, some of these details on this worksheet is a little tricky, so you might need a few hints or suggestions, but good luck.